Okay, now let's move on to another subtopic, which is 8.4, interference of reflected light in thin films. Okay, thin film is a thin layer of material that has a different index of refraction than its surrounding. Okay, this is a picture of a soap bubble. You often seen bright bands here, bright bands of color. This happen when light reflect from the bubble. Okay, same goes to this picture. This is a thin layer of oil floating on water. These two are the result of interference in thin film. Okay, these two situation is also can be shown schematically in this diagram. Okay, here we will see we have three layer here or three medium here, air, soap film and glass. As you can see for the bubble here, soap bubble here also have three layer, which is the outer one. The outer layer is air, and then the middle one is soap film, and the bottom one, which is the last layer, which is in the bubble, we have air. Okay, same goes to this thin layer of oil floating on water, means that outer surface, the first layer here is air, the second layer is soap film, and the third layer is water for this picture. Okay, and then for this diagram, air, soap film and glass here, incident ray light 1 here too, ray 1 here. Then from the upper and lower surface, each is the reflected ray from the upper and lower surface, then comes together to the ray 2 and ray 1 in the eye at P and undergoes interference. Okay, these thin films are the responsible for all the colours that appear in soap bubble ataupun dekat oil slicks ni. Two factors taking into consideration for the interference in thin film, which is the first one is optical path difference between two reflected ray. Second one is phase change due to reflection. For optical path difference between two reflected ray, this diagram shows that incident light here travel from a refractive index of medium N1. Okay, medium N1, and here is symbol for refraction or refractive index. Okay, N1 travel from N1 to surface of N2 here. Okay, at the surface, the ray, part of the ray is reflected, which is as ray 1, and then another will refract. Okay, we refract at medium N2 or refractive index of N2, travel for N2, and then at the surface here, at the bottom surface here, the light will reflected again. Okay, reflected again as ray 2. As you can see here, ray 2 travel extra optical distance of 2 nt compared to ray 1. Okay, optical distance means that delta L. As you can see here, the green one is ray 1 and the purple one is ray 2, which is we have optical path difference here, delta L is 2 nt, and here represent refractive index for N2, T represent thickness of this layer or this medium, which is medium N2. Okay, for phase change due to reflection from lower to higher refractive index or from less to denser medium means that there is a phase change, which is pi radian. This diagram shows that the incident ray travel from air to film. For surface A means that from less to denser medium. And for surface B, the incident ray travel from film to air means that from denser to less dense medium. This diagram shows how phase change happen or PC happen. This happen when incident ray travel from lower to higher refractive index or from less denser medium to denser medium. For no phase change, which is NPC, the refractive index is the incident ray travel from higher refractive index to lower refractive index, or we can call it from denser medium to less denser medium. Okay, let's check your understanding. Okay, the first one, refractive index is N 1.5 to 1.4, means that denser to, is there any phase change for reflection? Okay, denser to less denser. What happened to ray 1? Ray 1 has no phase change. There is no phase change because denser to less dense. Second one, when reflected at this point, it is from ray from 1.4 to 1.3. Refractive index here is more than 1.3. Means that ray 2 will be no phase change, also no phase change, higher to lower. Here, for B, higher to lower, ray 1 is no phase change. Ray 2 is lower to higher, there is phase change here. And then for C, 1.3 to 1.4, lower to higher, has phase change. And the last one, 1.4 to 1.5, lower to higher, also has phase change. You have learned how to identify phase change or no phase change of two reflected ray. And then here we will see whether these two reflected ray is anti-phase or in phase. Okay, this diagram is a thin film which is reflected light of phase difference is pi radian, or it happens only have one phase change. Okay, firstly, light is partially reflected at top surface A and bottom surface B of the thin film. As you can see here, we have incident light, okay, travel from air, okay, refractive index air to the gasoline. Now the first one is surface A, and then gasoline to water is surface B. What happened is ray 1, the incident ray, which is travel from less dense to denser medium, then ray 1 will have phase change, while ray 2 travel from denser medium to less dense, means that the ray 2 here we have no phase change. Okay, no phase change. Then this condition, what happened is these two rays, which is the ray 1 is phase change, ray 2 is no phase change, means that these two rays acting as anti-phase coherent. Okay, then ray 2 travel approximately to anti further than ray 1. Then interference occur, overlap the two rays, which means we have here whether constructive or destructive interference. For constructive interference, we will use 2nt equal to m plus half lambda. If the overlap is dark, means that destructive interference, we will use equation 2nt equal to m lambda, which is m is equal to 0, 1, 2, 3, 4, and so on. Constructive interference occur for minimum non-zero thickness. This is known as reflective coating. T minimum for constructive interference, M equal to 0. For destructive interference, T minimum, M is equal to 1. Okay, next case is reflected light with no phase difference, which means that 0, 0 or 2 phase change. 0, 0 means no phase change, no phase change. Okay, no phase change for ray 2, no phase change for ray 3. And then 2 phase change means that ray 2 phase change, ray 3 also phase change. Okay, this happens when light is partially reflected at top surface A and bottom surface B. What happened here is ray 1 travel from air to soft film. Okay, air to soft film means less to denser, which is ray 2 has phase change. And then soft film to glass means that also less to dense means that phase change. We have two phase change here. What happened here, this condition, we call it as in phase coherent. Okay. Ray 2 also travel approximately 2 nt further than ray 1, and interference occur when the two ray overlaps. These sources could be constructive interference or destructive interference. If constructive interference means that we will use equation 2 nt equal to m lambda, and destructive interference we will use 2 nt equal to m plus half lambda. As you can see, the formulas is still the same as before, but vice versa. Okay, constructive interference 2 nt equal to m plus lambda, but destructive is 2 nt equal to m lambda, which is vice versa lah. Okay, 7. Destructive interference occur for minimum thickness, a non-zero thickness, thus is known as non-reflective coating. Okay, T minimum minimum thickness for destructive, M equal to 0. Sorry, we have a correction here for the diagram at ray. As you can see, statement number 2 and statement number 4. Okay, the correct statement is here. Okay, the summary for thin films interference. These are the keywords for indicate constructive interference, which is strongly reflected, appears or clearly seen, being observed, and then bright. For destructive interference, the keyword is non-reflective, okay, missing, unseen, no light is found, or dark. There is the keywords to identify constructive or destructive interference. These two are the cases of thin film of interference, which is air soft air and air oil ground. Air soft air is antiphase, air oil ground is in phase. Okay, how we get antiphase or in phase? Look at this diagram here. We have air soft air. Okay, air soft air. For air soft air, let's see. Air soft air here, we have incident ray. Okay, incident ray travel from air to soft. For that surface, ray 1, we have air to soft means that refractive index N1 to N3 means lower to denser medium. Low to denser or less dense to denser medium, which is phase change. Then we get PC for first ray. Okay, the second ray travel to the second surface. Okay, for second surface here we have soft to air. Soft to air. For soft, and air. Sub is 1.3 refractive index, air is 1.0, means that from denser to less dense, which is no phase change, NPC. Okay, no phase change. NPC, we write down here NPC. PC and NPC means that one phase change only means antiphase. Okay, antiphase, because only have one PC. If antiphase, we will use this equation. Okay, if the question state that strongly reflected means that constructive. Constructive, we'll use this equation. If the question states that destructive means that non-reflective or missing or unseen, we use this equation. Okay, now let's take a look at this diagram. Air, oil and ground. I label there oil for 1.5. So air 1.0 to 1.5 means that less to dense. Okay, less to dense. If we can see is PC, and then oil to ground. Okay, 1.5 to 2.0 also less to dense. For that surface, less to dense also PC, means that 2 PC here is in phase lah. Okay, PC in phase. If these two ray is NPC and PC, means that no phase change, also in phase. Okay, also in phase. 0 or 2 phase change means that NPC or PC. Okay, if this condition happen, it's also in phase. In phase coherent. Okay, for in phase coherent, we also have destructive interference. Okay, destructive interference, we use this equation. And for constructive interference, we have this equation. Okay, exercise 8.2. A thin film of gasoline floats on a puddle of water. Sunlight falls almost perpendicularly on the film and reflects into your eyes. Although the sunlight is white, since it contains all colors, the film has a yellow hue because destructive interference has occurred, eliminating the color of blue, which is lambda equal to 469 nanometer from the reflected light. If the refractive index for gasoline and water are 1.4 and 1.33 respectively, calculate the minimum thickness of the film. Okay, given and gas is equal to 1.4 and water is 1.33. Okay, lambda is equal to 469 nanometer. And we need to find the minimum thickness. Okay. Okay, let's draw a schematic diagram for these three medium, which is first at incident ray is air, the second layer is gas, and the third layer is water. Okay, incident ray partly reflected and then refract, which is reflected as ray 1, and then for second surface also reflected at ray 2. Okay, as you can see here, we have two. Okay, now we must identify whether these two ray is in phase or anti-phase. Okay, ray 1 first. Ray 1 is from, okay, there is two surface here. The first surface is air and then gas. Okay, air and gas. Incident ray is travel from air to gas, which is medium refractive index is 1 to 4. 1 to 1.4. 1 to 1.4 is less to denser medium. Therefore, the ray 1 is PC, which is phase change. Okay, PC, write down PC there. And then, for second ray at that surface, gas to water. Okay, gas to water means that 1.4 refractive index to 1.3. From denser to less lah. Okay, denser to less. Dense means that no phase change. Okay, no phase change. PC and PC means anti-phase. Only one PC kan? Jadi anti-phase lah. Anti-phase kita nak tengok konstruktif ke destruktif. Oh, terang jelas kat situ dia bagi tahu destructive interference. Jadi kita guna rumus anti-phase which is destructive interference. Okay, rumus. Kita tengok rumus untuk destructive interference bagi anti-phase adalah sama dengan 2NT equal to M lambda. For minimum thickness, T minimum, M for destructive interference anti-phase is equal to 1. Because M cannot be 0, because when M 0, T also equal to 0. Tapi kat sini kita ada T. Sebabkan layer of the gas tu. Jadi M paling minimum kat sini adalah 1 lah. For constructive interference, anti-phase, kita guna rumus 2NT equal to M plus half lambda. Untuk minimum thickness, M kita pakai kosong. Minimum thickness untuk ni kita pakai M equal to 0. Bila kita gantikan M equal to 0, kita dapat thickness lah. Okay. Okay, sekarang kita substitute nilai. N tu kita pakai N gas. Okay, sebab thickness tu ada dekat gas tu. Jadi N 1.4. Darab dengan T yang kita nak cari equal to M equal to 1. Dan lambda is the wavelength 469 times 10 power of negative 9. Dan last kali kita akan dapat jawapan untuk T minimum is equal to 168 nanometer. Thank you.